got a phone call from one of our customers who is having an issue with his electric radiant heat mat. He has two mats in there. One's working, one isn't. Go inside, see if we can investigate to see what the issue is and get this floor working again properly. Basically, we've got a mat installation, two mats, one custom mat that goes around this side of the room. The other one is a standard mat that is in this area. We found by testing the mat that the mat in this area has 65.7 ohms, which means it has resistance and therefore will work. When we test the other mat, the red to black, there should be a resistance reading. We're getting OL, which means we're getting no resistance. This basically is a dielectric strength tester, and what that piece of equipment does is send a current through the wires to hopefully find where the break is. These wires are insulated with this stainless steel braid. So what will happen is where this stainless steel is cut, it will arc in that spot, causing the stainless steel braid to weld to the conductor inside the sheathing. Once that happens, we'll be able to locate where the break is, make the repair, and be done. So we're going to hit this now at 500. It's holding, so we'll turn it up a little bit at a time until we get a trip, which we did there. So now we hold down the reset button and hit it, and that noise is the machine actually tripping. So what it's doing now is the electricity, the current of the electric has gone through, and it's at the break now, causing a spark and hopefully causing the weld. This is an infrared gun, and basically what this does is it has the ability to sense heat. So that spot that is arcing right now is getting really, really hot with all of the energy going through it. So what we'll do now is we'll walk around the room and see if we can find that hot spot. So what we've effectively done here by juicing this mat with 1000 volts is we've got our weld from the conductor wire inside the sheathing to the stainless steel braid. So the ohms meter is testing from the conductor to the braid. Normally you would want this open, but we wanted it to weld so we can now heat up the mat and find where the hot spot is. So we're getting 27 ohms, which is a pretty good reading for a weld. So now what we've done is we've taken this variable power supply pack down here that has a dial on it. We've hooked it up to the mat to heat up the mat. This is basically acting as if the line voltage from the home is heating it up. The advantage to the variable power supply is we can go up really, really slowly, because there is a chance that if we use too much of a current, it can blow out the weld that we've just created. So this is ohms meter, amps meter. This is going to show us how much amperage we're pulling through. Ooh, that's looking good. That's good. What we're trying to do is get up to 1 amp and let that go for a while. We're at 1.06 amps. So now the mat is heating up at 1.06 amps, which is a lot slower than it would heat up under normal circumstances. This mat is probably 4 amps, around there. So it's going to take a little bit longer to heat than it would under normal circumstances, but we'd rather do that than risk blowing out the weld and having to start from scratch. We've energized the mat, we've heated it up, and we've found our weld, or basically where the break is. You can see that that's really, really hot. It's red, much hotter than the rest of the floor. So basically, the mat is coming and doing this. I don't know if you can see the lines or not, but that line, that one wire is coming down, and then where the break is, that's where the hot spot is, and then it's blue after that, which means it's cold. So we know that that is the spot. We're going to pop up this tile, find where the break is, and our next step is actually to repair the mat. Before you start hitting the tile, after you find where the break is, you want to make sure you scratch out the grout joint very carefully, because if you don't, and when you hit with the hammer, there's a chance that other tiles that don't have an issue under them can crack, and you want to minimize the damage as much as you can. We've found the break, which is all this black stuff, what you see here, and the fact that it's sparking. We still have electricity running through there for the sake of this exercise, but all the black is from the weld, from the electricity going through. This is what electricians call arcing, that spark you see. That's how we find the break. Now what we'll have to do is pick up the rest of this tile and this tile to get enough wire to where we can make our repair, and that's the next step. Okay, so now we've finished clearing up the top layer of thin set. We've got the wires apart. Obviously you can see where the break is. Now the next step is to make sure that this is the only break, because when we do blast it, it's only going to arc at the first break. So what we have to do now is test from this wire to this wire to see if we get continuity. If we get continuity and we get an ohms reading, and we're okay with the ground wire, then we can make the repair and we're done. If we get an open reading on one of these sides, then we know there's more breaks, and we'll continue to test from that spot. Okay, so what we're doing here is we are basically completing the loop, right? We want resistance, we have to have the loop be continuous. We have the ohms meter on each alligator clip on either side of the mat, and what it's showing us is we have 36 ohms of resistance, which is good. That means there's not another break. We can repair this and then test again from where the thermostat is to make sure it's a good repair, and we're done. So that's a solder sleeve that he's got on there. Basically a piece of plastic with a small piece of metal in the middle. And what he'll do is he'll heat that up until the metal melts and solders the resistance wire together. That's step one in a two-step process. He's got to do that twice. So there's basically two splices for the one break. And then he'll do the same thing with the outside sheathing, or the stainless steel braid, which is the ground fault. So that will mean the GFI will still operate properly. Pull that resistance wire, or pull the stainless steel braid over top. Heat shrink that, and the repair is complete. Okay, back at the thermostat. As you can see, we are testing black to red, which before was reading OL, or open. It is now reading 35.6 ohms, which means we have resistance throughout the mat, which resistance equals heat. Okay. Our next step is to take the dielectric strength tester, run 1,000 volts of current through there to make sure that, number one, there's no other breaks that we couldn't detect with the ohms meter, and also to make sure that the welds that were already done are secure as well. We're going to start at 500 volts. Before, when we were hitting that at 500 volts, it was tripping the GFI in the machine. Now that means it's holding, and now it's taking 1,000 volts and held the charge, so we know we have a good mat. Okay, that's it for today. We have a good repair. Homeowner is happy. Hope you enjoyed watching this video. Any questions, again, please call us at 800-409-9276.